Hey guys, Joey Nuggets here. I wanted to show off this cool little jig I found online. There's a guy by the name of Michael Hackney who has a series of awesome videos explaining the functions of the Kiss slicer. Um, he also has a video that goes through calibrating your E-steps. And if you've ever tried calibrating your E-steps before, you know it involves measuring filament and doing some math. And the hard part isn't so much the math, it's measuring the amount of filament that was sucked into the extruder. So with this tool, as you can see, it combines a couple 3D printed parts with a standard caliper. And how it works is you mount your caliper into the top of the tool. There's a hole here, so you can put a screw in there which kind of locks the top in place. And the other part of the tool is what we call the filament holder. There's a slit in here where you would attach your filament. So your filament would come down off the spool or whatever into this little slit. You would tighten down on that screw and it would have a hold on your filament. And then what you do is you hold this on top of your extruder. You would kick off the G code that Michael provided, or you can just extrude 100 millimeters however you would normally do that, either through Octoprint or through the LCD screen or whatever. But it's preferable to use the G code because he actually decreased feed rate, so it's pretty slow. It actually starts slow and then it ramps up a little bit faster and then it ends slow. So I would recommend using that. And when the filament is extruding, it pulls down this piece, which in turn pulls down the depth gauge, and then you can read exactly how much was being extruded. So that's an overview of this tool. I'm going to show you how it works in operation, and I think you'll find that it's very handy. A couple of things regarding the caliper. I had to make some modifications to this caliper. This is a set that I have dedicated to this purpose, but as you know, on most calipers there's a little thumb screw here, and that kind of gets in the way. So I turn it over. There's a little screw usually here on the back. Just pull it off and just remove the thumb screw, and that'll allow you to have, the maximum amount of travel. So you can ensure you're getting over 110 millimeters worth of travel in case your printer's over extruding by 5 millimeters or so. You'll have enough buffer in here to truly measure any sort of significant over extrusion. Under extrusion is not a big deal, right? Because there's enough travel to measure 100 millimeters out of this. So that's what I did. And there's also oftentimes a little screw or something on the bottom, or a plate that holds the depth gauge in place. You may, depending on your caliper, you may need to pull that off to fit inside this channel. So that's not a big deal. That's just an easy modification to make. When I mounted this into this block, there's a set screw hole here that allows you access to secure a set screw to butt up against the depth gauge, and that's what locks the depth gauge in place onto this filament holding block here. I printed out a separate part separately to show you what it looks like. You can see on the back of the block there's a space for putting in a nut, and then the front you could just feed an M3 screw or whatever size this is and secure it to the nut, and this way that'll give you some clamping power for your filament. And here's the other set screw on the side where you would just feed in one of those little grub set screws that will butt up against the depth gauge that goes in through the top hole here, or this top slice. So that's how it goes, and then this piece just slides onto the bottom of the base. So that's kind of how it works overall. I'm going to show you how this functions in practice. I've already calibrated my E-steps, so we should be good to go. What you want to do is preheat your printer, your extruder rather, to whatever temperature you normally print your loaded material at. Feed your filament through this slit and make sure it's straight, and just place the bottom of this on top of your extruder, and also make sure that the path that the filament takes is in line with the hole on the top of your extruder, so that path is as straight as possible. And then you're going to need to just hold it on top of the extruder, run the G code, And when it starts, it'll pull this down and you'll see the reading on the display, which is a lot better than trying to do this with, a Sharpie or marking it and then trying to measure it accurately. This improves your accuracy, 100 times. So let's get down to it and I'll show you how it works. Okay, so my printer's preheated to 220 degrees. That's just what I use here. I'm doing a voiceover, so you're not going to hear the beep when you run the G code, but it does beep to give you some time to zero out your calipers. So I just printed it right now, and it's just about to start, and you'll start to see the display moving there. And as we watch this, the display will start to increment to tell you how much filament you're sucking into the extruder. And if you watch the tool, you'll see that as the filament is fed through, it's pulling down that channel. So as I said before, the filament or the G code will start off slow. It'll ramp up in speed towards the middle of the print, and then it'll taper off and slow down at the very end. And this allows you to get a nice accurate reading, and you'll be able to tell if your printer is over extruding or under extruding. So we're about almost done here with the print. You can see I'm at about 85 millimeters. And once the extruder reaches 100 millimeters, or what it thinks is 100 millimeters, it'll stop. And at that point, you'll be able to take your final measurement and have a really accurate measurement of how much actual filament was extruded. So here we are at 97, 98, 99, 99.74 is what I came up with here. And that's pretty darn close. And I could probably call that good. If you want it to be anal and, redo the math and plug in your new value and rerun the test, you're, more than welcome to do that. I say why not, since we have an accurate way of measuring it now. So I'd say it's probably not worth it if you're doing it the other way, because there's room for error. But this is pretty accurate. So as you can see, I'm pretty close to the 100 millimeter mark, and I'll probably tune this to see if I can get a little bit closer to 100. So that's about it, guys. Let me show you how to do the math. Okay, now that we used our handy dandy caliper to figure out how much filament was actually pushed through the nozzle when we told the printer to extrude 100 millimeters, to figure out our E-steps, we're going to take that 100 millimeters that we were playing with all along here, and we're going to divide that by how much was actually extruded. If you remember, in my case, it was 99.74 equals. Now, I can simply take this and plug it into my slicer's extrusion multiplier and be done. But most extrusion multipliers are at 1. So I'm pretty close. Like I said, I'm pretty dead on here. Alright? Now, if we wanted to get our E-step value, you simply do another calculation. You would take this number here, this 1.002, and you're going to multiply by my old E-step value, or my current E-step value, which is 142.007. And to get yours, you'd have to run the M503 command in a terminal window to see what your current E-step value is. Mine is 142. So now if we say equal, my new E-step value would be 142.3 instead of 142.007. Okay? And that's it. That's all you have to do. We could do another example. 100 millimeters, what we're playing with. Okay? We're going to divide that by what was extruded. Let's say we only extruded 94 millimeters. Now we have a value of 1.06. Okay, that makes sense. You could take that 1.06 and that could be your new extrusion multiplier. You would have to increase it a little bit because you're under extruding. Alright, now to get the E-steps from that, you would just multiply this by your current E-step value. Mine again are 142.007, and that leaves me with 151.07. That would be my new E-steps. And that's pretty much it. Not too hard. Just remember the formula. 100 divided by extruded multiplied by your old or current E-step value equals your new E-step value. That's it. All right. So thank you for watching. If you enjoyed this video, let me know. Maybe I'll make some more, or maybe I won't. Who knows? All right, guys. Thanks a lot. Bye-bye.